like clear, but for like importing uniform, we have to do from spicy. That library I got forgotten.
Okay. Okay. So actually, I'll convey that to the team so that we can check on that. No issues. Last question, right? So I'll just ask sir to check it once. Last question.
Yes,
Okay.
sir. Last two questions were connected to that.
So it had the SciPy library, like there was some use of SciPy in that.
Yes, sir. Yes, sir.
Okay, okay, okay. Sure. I'll just tell sir that if something can be done on that. Okay. So
Actually, sir, it was totally 9 marks. 9 marks question
yeah,
total.
yeah,
And
no worries. I will inform sir. Okay, and actually, sir will be taking your classes next week as well. But before that, only I will inform sir. And on Monday as well, in case there is some clarity which is not provided, you can just ask sir as well on Monday. Okay. Yeah. So okay. Yeah, Jaydev, what was your doubt? You can unmute.
Yes, sir. Sir, my doubt is do you have that question paper of OP2?
No, no, I don't have. I have not made this one, so I don't have the
Okay.
paper.
So,
If you have, then you can maybe share, or if someone has the paper, they can share
no,
it.
I don't have. Actually, if anyone has, then
I can
it will.
share.
Yeah, yeah,
Yeah, yeah, please share.
share it.
Are the other scores out for OPP?
I think it's not out yet.
Like, we can't even check our answers, right?
They will give you solution collab
Okay, okay,
soon.
okay.
Okay, you will get that. Yeah, yeah.
And
Score will
sir,
probably be
Uh,
out next week. They take around 10 days to process the scores, so you can expect them next week.
and sir, regarding the Kaggle assignment 3, can you like give us some suggestions, or can you
I
walk us
have
through?
I have no idea on the Kaggle assignments. You have to first tell me what it is about because we have a different
It is,
instructor for
it
Kaggle
is,
assignments.
it is
It is
sentiment analysis.
week 9 to 12.
Yeah, yeah, that I know. He told me it will be on of the later week. So it is sentiment. So you are given some reviews and you have to analyze
Yeah,
sentiment
yeah.
of that, right?
Yes, yes.
So you can basically, if you remember, we did did a session in week, which week was that? Week 10 about semantic cosine similarity and TF-IDF. Yeah,
Yeah, I did
yeah.
all those, but the score is not up to the mark. Like,
See,
how
in
do I?
sentiment, the problem is if you use simple ML model, the score will never be up to the mark. You have to use DL models for sentiment. So you won't be getting very good scores in sentiment as such with ML models. Sometimes you do, like sometimes if your pre-processing and all is excellent, you do get.
Yeah,
But
I'm that thing. The pre what like is it magic or something? How do I do the pre-processing that I can
have
get?
you done the TF-IDF and those
Yes,
things?
yes,
Feature
yes, obviously,
extraction?
yes, I have done, and I'm getting like 62%.
I think that is fine. That is not bad.
Then some of these guys they are like scoring 80, 70.
Okay, okay.
How?
Some
Yeah.
like highest score is around 80.
So yeah, 80 is the highest, and my rank on leaderboard is.
Then you can try different models. That is what
I
that's
have
what the
tried every
pre-processing.
single model and hyper tuning them, every single model, every single possible combination. I've tried XGBoost and everything, every possible thing. And at last I found out that that Ridge model is performing the best. Even that is giving me 62. 65 is not like, it is not crossing the threshold.
Okay. Have
Like,
you tried models like random forest and all those
yes,
things?
yes, yes, bagging everything, everything.
Okay.
Oh,
Then you
oh.
can maybe try grid search.
Yes, I've tried grid search too. I've tuned using grid search only. I've almost like trained and hyperparameter tuned. I've tuned 7, 8, and I've like tried 15 models.
15 models you have tried.
Yes,
A
even
logistic
outside
regression is
SKLR.
also working.
Yes, I've tried that too, but the scores are not like drastically improving. Max 6, 60%, 62%. That's it.
Okay. Uh,
So, sir, regarding that, like, can the threshold be reduced to 60?
what is
Since,
the threshold right now?
why can I say that? I think it's 65, right?
no, no, no. 62, 62.
For all the Kaggle assignments or for specifically this one?
No, only for this
Acha,
sentiment
acha.
on.
Okay,
Yeah,
okay,
there
okay,
is
yeah.
one session. Okay. Yeah. You have
Uh,
seen week 11 session or week 10. There is one session which is
Ah,
Yeah,
TF-IDF
yeah,
I've
week 10,
seen,
session.
week
yeah.
10. Week 10 it is. Yes.
Natural language processing. Yeah.
Yes, yes, week 10. But I know, I understand you must have seen that, and you're not getting a good score. That you need to do hyperparameter tuning for that. If you have tried all the models and none of the models, even the boosting and all, is not giving you a good score, you
Yeah,
should try.
I tune and the tuned score is only 62%. Even like without
Then,
tuning,
then
it's
the
far
problem is
worse.
your parameter combination. I know it is a hit and trial, but your parameter combination is not optimal. What you're tuning, you need to try different sets of parameters.
Yeah, for the rich thing, I like tried from 0.5 to all
Is
possible.
your
Like,
best model Ridge currently?
yeah, yeah.
Okay.
Alpha is I set it to
Try
1.8.
tuning on the bagging boosting a little more, because you should actually get some good model from there. It generally gives good results, and sentiment and all. These are quite easy tasks. Have you tried MLP, MLP regressor, or MLP classifier? Have you
No, I
tried that?
haven't tried
Try
MLP.
it once, because neural networks are very good for natural language processing. Try
Okay,
MLP
okay.
once.
Okay,
Okay.
okay, okay,
I'm
okay.
not saying that you're
Sir,
going to get the best score there, but just try it out once, because it generally is very good. It, actually, sentiment is done using neural networks only. We don't do it
Oh,
with traditional models anymore. Of course, in MLP you will be doing that, but in other courses in DL and all, you will learn with neural networks. So just try it with the MLP. Build a deep one, like add many layers to it. Okay, you have an option, right? You add all those hidden layers in MLP. So
ha ha
add
ha.
many hidden layers. Try at least 5. You start with, then maybe 7, 8 hidden layers, and your model becomes much deeper. So try with that. You should be able to crack a good score with that.
Yes. So now if I like increase, like if I make the model very heavy,
Yeah.
it would take much time, like a lot of time to
It would.
submit.
5 layer is not heavy actually. A heavy model means 1,000 layers and something like that. 5 layers is not heavy. You won't, and your
So
data set will be much smaller also than the DL ones that we give for DL. So it would be fine. You can work with that. Shouldn't be an issue.
I tried like hyperparameter tuning XGBoost in the Kaggle. It took me almost 1 hour, and then I like stopped it. Then also,
XGBoost is very heavy. It is more
yeah.
heavy than a 5 layer network, so it will definitely take more time. Like I remember that even in my time when I used to work with XGBoost, it used to always take a lot of time. So that is
But
fine. You don't need
for
to worry about it.
for the previous two Kaggle assignments, XGBoost gave nice results
Yeah,
after
yeah.
tuning.
Generally, see, bagging for MLP, bagging boosting is the universal solution. It generally gives good results for everything. But here, since it's sentiment, maybe it's not doing that good a job, and you have to try some neural network, and that might be better for the sentiment case.
Yeah, I tried bagging, but it was like 55,
Did you try
57.
the random forest?
Yeah, I tried that
So
too.
not good
Not
in
good,
there
not
also.
good. The Ridge is the best I found.
Okay, so stick to Rich for now, but you just try MLP once. Okay, I think it might do
sir,
the job for you.
sir, in my case, SPM is performing better. Like, I mean, I'm getting
Actually, that
60,
completely depends on your
0.6.
pre-processing and your that the parameter set and also it any model can do better. Like suppose like I if I attempt, I may be getting the best thing from decision tree, right? So it's completely subjective actually. There's nothing fixed about this. So depends on your parameters, but don't share your
Uh,
parameters with someone else. I would
no,
say,
no, no.
yeah.
Also, sir, my score is not increasing. Like, I'm only getting 0.6 and not
I will
increasing.
ask the instructor, the Kaggle assignment instructor, maybe if he can do something on the threshold, maybe just reduce it.
Yeah, yeah.
I don't know. I mean, how they are getting 0.84, 76
Exactly, exactly.
something.
Like, what are they doing? Like, we are also training and they are also
Either,
Anyone who's
training.
getting 0.84 here in this meet?
I mean, they could be, I mean, professional or already from
See,
outside
Sorry.
world,
sometimes
I think.
sometimes it might be a luck factor also. Sometimes it might be a
Uh,
very good factor, like you've done a very good job in that. Sometimes you just hit a model and it works, right? You hit the lucky draw.
No, no, no. Like, where is this luck coming? I don't get it. Like, they are also pre-processing. We're also doing. Like, are they doing some magic in
And
pre-processing, or
there,
there is some extra step?
I saw a guy named Aryan, or I guess he was lucky for the two times.
Yeah, like, how are they getting lucky? The data set is same for everyone, right?
It should be. Yeah, dataset doesn't change.
Yeah. Then how is this possible? Like, what are they doing? Like, we should learn. If they're like good at something, we should learn, right?
If
Definitely. Anyone here who's getting that kind of a score?
I think there should be like this thing that who are the top performers, their code should be public, and like we should be able to see that.
yeah, that's what I also came to say.
Yeah, maybe after we can request that. Like
Yeah,
after the assignment is done, then we
for
can
all the
do
three
that.
Kaggle assignments, if
Yeah,
that
yeah, for all the three. Yeah.
Yeah, yeah, I think that can be done. That is not a problem. That can be
okay,
arranged.
the best three in all the three Kaggle assignments, it would help us a lot. How they are
At
performing.
least their approaches to be shared, at least, because what they are approaching and what we are approaching, there is a minor difference,
Exactly.
I guess.
I think that can be done.
Yes,
That
sir.
is not a problem. We can arrange that. So I'll just tell Anirudh is the instructor for Kaggle. I'll just tell him if he can just add up that the
Also, if you talk to him, just ask him to take a class on it.
yeah, sure. He can take a class on it. Done. We can tell the TAs as well. Like class on what exactly? You want the class on pre-processing the language?
No, no,
That
no. We know the steps now. How to approach a particular
Like,
problem to get a good
yeah,
score.
yes, like how they are thinking, like to solve that problem.
Approaches basically.
Yeah,
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 yeah.
sure. I think we can
Process we know
arrange that.
what we
Yeah.
have to do. We have to create pipeline. We have to create column transformers. But what are the approaches that others are doing and we are not doing? That they are getting good marks and we are not getting it. Like I'm hardly able to reach 4.45 this one in this Kaggle. And I'm seeing that a guy whose name is Aryan, and he is getting throughout all the three assignment he has got 0.82, 0.89 like this.
Okay. Fine, no worries. I will tell Anirudh to take a class on this and maybe guide you with some optimal approaches for the
Yeah,
problem.
this time it's around 0.85, the top leaderboard.
When is the deadline? Has it passed or you still have?
No,
Today,
today is the
sir.
deadline. Today
Tonight
is
is
the
the
deadline.
deadline.
Okay, okay. So don't worry. I will tell Anirudh to just maybe lower down the cutoff a bit, right?
We
The
are
demand
using
from
only the models which are taught to us in the class. Maybe I, but
yeah, I think only those are allowed. Only can you use other models? Like, is it allowed
in the
to use?
first Kaggle assignment itself, the students were saying some other names which are new to us, totally new to me.
Oh, that might be an issue then. Maybe the person who's getting that good score, he might be using a deep learning model or something like that. Because if you use a deep learning model, score will jump.
No,
That
no,
is for
not
sure.
deep learning, but this class in this basic regressor and classifier models itself, there are new uh, something new cat boost something they are saying.
Yeah,
XGBoost,
there is Cat Boost
XGBoost.
also.
XG boost
It's
I tried the last time. That also didn't give me the good score.
Cat Boost is there. There is a model called as Cat Boost. We
yeah,
might
Something is
yeah.
new and students are asking, shall we use that or this? And they are using that. I believe. I don't know.
Yeah, we are open
yeah,
to using any
ideally in
model.
MLP we don't allow using of anything else apart from what is taught because even in the project you can't use. It's not allowed.
Okay.
So
I tried with whatever was taught in the class, but the scores are not improving. It's around 6.62.
it ideally shouldn't also like generally for NLP the models that we do in MLP course they are very basic models actually. We need something deep. Like you can try the MLP classifier ones, the neural network, just basic neural network which you have learned. You can try that once. That might help you because neural networks are very good to capture language.
I
So
tried MLP, but I didn't do grid search there. Well,
try
I,
grid search on that as well, and try a deep MLP. Like you add 5 to 7 layers of hidden layers in that.
okay.
That generally is useful for MLP because the deeper the network, the better the network. That is the theorem behind it.
So, like in our this notebook, how can we make GPU work instead of CPU?
You don't. I think you don't need GPU for this. You can make it work like that is not the issue, but you don't need GPU for this course. We don't require GPU usage.
For the hyperparameter tuning, it takes a lot of time.
If you need GPU, you have to use switch to PyTorch library. Then how will you switch to PyTorch library? That is not taught to you, right?
Oh, in
Because
SK.
PyTorch, actually, what happens is in PyTorch, you have something called as tensors. They are an alternative for NumPy arrays, and they have the GPU facilities available. So you have to write your code in tensor format. If you write it in the array format, which is basically what scikit-learn uses, you have to import a lot of additional things to actually get the GPU usage done. Because
Oh,
ML models are not meant for GPU usage as such. So that is why this does not come with an inherent GPU for you.
oh, okay, okay. So everything is on CPU.
Yeah, everything is on CPU. We don't use GPU in MLP. We use GPU in DL and all the DL based courses.
For MLP project also,
No,
we are
no, no, not allowed. No GPU, only CPU.
And sir, I don't think there's this like restriction on this model thing that we have to use
Me,
only the.
I also have no idea. If it's not there, then you can use the other models also, some advanced models. That is fine. If it is not specified in the question that in your question statement or your instruction statement that you don't have to use this or you just have to use this, then it's okay. In project, we specify that you can't use something outside the course. Are you sure there is no such specification about using something?
Yeah, I don't think I once asked sir, and he said that I'm free to use any model.
then it's okay. Then you can try something like a deeper model. That is fine. If sir has allowed it, then it's okay. Shouldn't be a problem. But don't worry about the cutoff thing. I will tell sir, okay? So that I will make sure I tell that you reduce it to a bit, like maybe 60 or 55. That will help out, right?
Yes, sir.
Okay. Anything else regarding the OPP? Any other query? Like I saw a lot of things on discourse on the OPP. So if you have any other query, we can talk about that.
Yes, sir. Yeah, I have a doubt.
Yeah, yeah.
Before that, the way we are doing Kaggle assignment, what is the real life scenario that in universe of ML learning? Is that same way Kaggle we are doing?
Yeah, kind of. Kind of. It is still quite simple. The project will give you a little better idea of the real world thing.
Yeah. For practical things, I think this we have done OPP. So that one I feel this is the basic. This is the true good one.
If you are good
Or
with this, then the other things are going to be quite simple, because here in this course you do everything from scratch, right? You do all pre-processing, splitting, training, evaluation. Then if you go to the real world things, it becomes much more simpler to work with once you are done with it. Like this course builds the fundamentals for the real world projects and all. Most of the real world projects are done using DL, but once you are clear with the fundamentals of this one, then all the real world projects become simpler to work with.
yeah, sir. One thing. Can I share a screen? I just want to
Yeah, yeah, sure.
show this. Yeah. Okay. How to go? Okay. Okay. And
So, sir, the top guys are using deep learning models, you say, right?
I'm not saying that. I'm saying they might be.
So I was getting 0.63.
yeah,
Can you repeat this? I couldn't
zero
get
point
you.
six three. So yeah,
Yeah, so for Kaggle assignment, I was getting 0.63, something like.
Yeah, I think most of you are getting something around that, right? That is,
Yeah, I got around 0.62,
yeah, that
6 to 3.
means most of you are getting similar scores for Kaggle.
uh, yes, sir. Yeah, this it is visible, isn't it, sir?
Yeah, yeah, it is visible.
So okay, this is some model building. Yeah, question. Where is question? Yeah, this question. So one hot encoder. There is one question. One hot encoder. Active. Where is active things? My question. This is not running. Okay. Okay. 7 question.
The
8 question.
column name was wrong, na? Physical one we have to take.
Okay. Uh, uh, there was an active question, isn't it? Active one hot encoder. Yeah, this. Yeah, okay. Okay. Uh, yeah, this question, sir. This gender is a column, feature column, and smoke is a feature, and alcohol is also feature. But active is not a feature. Okay, sir. This is the data of a feature. So how can we do one hot encoder to this? Is it possible?
1 second, let me go through it
The
again.
column name was physical active. In that, this
Okay, they have made a spelling mistake, like a name mistake here.
physical, yeah, physical something like that was the
Yeah.
correct.
Yeah. For this, we get mark, isn't it, sir?
You
3
should
marks,
get
3 marks.
marks. Can you tell me this? Can you just
Yeah,
write the question number in the chat box? I will just mail it to sir. Just write the question
because I
number.
have struggled 10 mark. There is total of 10 mark to this question. Because of this, I have struggled very much. How
So the
how to
error is
check
the
this?
column name, right? They missed out the complete name and wrote an incomplete name, right?
Yes.
Yeah, they have given another thing. They have not. This is they have given another thing. Data of active.
So the column names,
In there
then
is
you will get it.
yeah.
Yeah, yeah,
Where is
I got the issue. I think this is fine. We will give you marks for this. This is fine.
okay?
Because this is a column name mistake from the question paper side only. So you should get marks for it. Just write the question number in the chat box one. I will send it to sir.
Yeah, question number. Now question number 9.
So just
So
write
Nine.
it.
Yes.
we have two parts. This question have two parts. Question number 10 and 11. It is a pre-processing
Yeah.
question. Two parts. One is of 3 marks, another is of 11 marks. So although they give the output here, sir, active, but the column name is physically something like physical activity. That is a column name.
Yeah, got it.
Sir,
No,
will we get full marks
just
on
write
this?
all the questions. Just write the name of the question number in the chat box. I will just send it to sir. We should get marks for it. Like according to me, they'll give you marks for this. This is fine.
Okay. Sir, when will we get the result?
Probably next week.
Sir, question 10 and 11 was there, not question 9 and 10.
10 and 11, right? Okay.
Yes,
Just
sir.
just write it once in the chat box. I'll just copy it from there only. Any other question in which any mistake was there?
Yeah.
Another?
No, one was there was one question. It was very lengthy. So how have they have done? Because I have done modeling things within a half an
It's
hour.
in this
Modeling all.
one, this pre-processing this question.
Yeah,
And
it's so lengthy. How they have given this?
So by the way, paper was so easy. I just joined.
Yeah.
This question is actually from
Paper-
week number 3, maybe 2.
yes,
I got all the correct.
Yeah, it was easy, right? I also got that feedback.
Yes, it was easy.
Yes, sir.
Is it?
In fact, I
Sir,
would say both the
No,
OPPs were
no.
fine, right? Even one was quite simple. I had kept OPP one quite basic only.
Sir, but that is actually frustrating due to
This.
some technical issue.
Which one? OPP one?
Yeah, OP1 one is
Yeah.
actually
There
due to
were
some
some
technical
technical
issue.
issues. Right. I got it.
Sir, for the ratio 1 question, I was getting different answer.
Which set you have, Disha?
For ratio question, I got different answer, not this.
Which set you have? Version 3, version 1, version 2. Which version you have?
All are maybe same.
For
I think the
No,
A is the
all are
correct
not the
option.
same.
I
There
got
are
A
three.
option as
There are
well.
three different
What?
versions. Each version can have different answers.
yes. So version
Yeah.
3 have answer of D. Version 3 have answer D.
I had
181 ratio
version
33.
1. Version 1
And for
option
2,
I
it's
think
B.
version 3.
Version 3 is 181 ratio 33. The one who have version 3, the answer is 181 ratio 33. I already checked with my peers.
But I was not getting.
And version
Might be
2,
might be some code error. Disha might have made some mistake.
Yeah. This is actually very, sir. This is a tricky question. The question which, like, out of the box, this is the one. This is the one question in which we have to divide by 365 because number of days are given. So we have to convert into year first of all, and then
Yeah. They've asked in year
column,
for
new
that.
column, and yeah.
Okay, sir, this was the mistake only.
Okay. Then it's fine. Okay,
And so
meanwhile,
there is one
while you're here,
interesting
let me
thing.
just quickly make the end term announcement as well. Then we will move on to this OPP once again. So for
Yeah.
the end term, your end term is next Sunday, right? So for that, you will have week 1 to 10 and week 12. Week 11 will not be coming. So you can skip it. Okay?
Okay, sir.
Yeah. So week 1 to 10 and week 12. Week 12 is important. Don't skip that. But week 11, you can skip. So coming to that, for the question type, you will have mostly like 90% code-based question. We'll give you snippets and you have to answer based on that. And some general questions can be there, like suppose we give you some parameters and we ask you which like this model has these parameters or not. General parameters won't be too specific. Like if I give you n neighbors, which model has the n neighbors parameters? So you know it's k and n and k means, right? So these types of basic questions will be there. Level is more or less easy, should be able to get good marks. And prepare the collabs. For preparation strategy, don't prepare questions where you have to write code, because you don't have to write code, right? You have to just read the code. So just go through the collabs, live session collabs or maybe lecture collabs of the weeks. That should be good. And I think you have PYQs as well, right? So just go through them for practice. Okay, that is for the end.
So paper is already created.
Yeah, it is.
Okay, sir.
Yes, it is.
Sir, I think best is the PYQ, sir. Like more or less, if the senior said that more or less paper is similar to the PYQ, so
That
better
is
to do at
changing
least
now.
5 or
That
6
is changing
PYQ.
now. That pattern is changing now. You will see new questions.
Sir, at least 2, 3 new question, not like
The
10.
entire
If
paper
we have
will be
20
new
questions,
questions. There won't be any repeat.
yeah, values will be changed, na? Sir, right? Concept will be same, right?
See, concept to like if I say pandas remains pandas only, right? But I can ask you any question from pandas. PYQs will be good for practicing the concepts, no doubt, but it will be like training data and test data. You'll be working on training data, you'll learn those concepts and applying it on unseen data. It will be like that. Okay, there won't be any repeat. So don't go into that thing that it will be all PYQ repeat. There will be no question which will be repeated. Everything will be new.
No, sir, that's not. I'm saying ki PYQ will be repeated. I'm saying ki similar to PYQ means that like sometimes the question is asked from KNN, find what is the neighbors or like how many total parameter we use the grid size series. The similar type of question. Yeah,
That is more or less the same.
similar means exact. Yeah, not like
Similar
common
question.
entity.
Yeah.
Similar,
If
sir.
you do PYQ,
Similar.
you will get a good idea of what type of
Yeah.
question will come. Yeah, that is true.
And that is 100% sure, sir. No question repeat in PYQ except BDM. So BDM have a repetition of the question.
Yeah, in MLP as it is, see, it's a code-based subject, right? So questions will always change because we can have so many variations of the same code. So that's why there is. Yeah, but if you practice PYQ, that will give you a good practice of questions. That I can agree upon.
Yeah, from particular topic, like from model building, classification, this type of question comes. Regression model, decision tree, this type of question comes.
Yes,
So,
yes.
yeah,
I
similar.
agree.
Yeah.
Yes, it will be similar. Yes. It will be similar. And it's going to be easy. Like, it's not difficult. When I meant to say that if PYQ is repeated or not, it's not going to be repeated, but it's going to be easy. You won't find it very difficult to work with it. Okay? It's quite simple.
Yes, sir.
And week 11 you can skip. So do you want me to take up week 11 in the live session, or shall we do some discussions regarding the end term and just do a revision or something like that?
Yes, sir, we can do.
Yeah. So week 11, see, just quickly a summary for week 11. You have transfer learning. Transfer learning simply means when you have a large model, you apply the training data of that, you apply the parameters of the large model to some other model. That is what transfer learning means. Go through the lecture once. It's an interesting concept. You will see it more in deep learning. But since it's not coming in the end term, let's not focus much on it right now. We can do some revision, right? Will that be okay, or you want me to take up transfer learning? Whatever you want, we can do that.
Revision.
Week 12 complete.
Yeah, week 1 to 10 and week 12. Week 11 will not come. So 1 to 10 will come and week 12 will come.
Sir, what is there in week 12?
Week 12 is time series modeling. That is very important. You will see a lot of questions from it. So please.
That is done in the discussion.
It will be done next week. It will be done by Manoj sir next week. He'll be, yeah, because time series actually Manoj sir takes that up. So he'll be taking it up next week. So Monday and Thursday, 2 sessions. In case finishes on Monday, there'll be another revision session on Thursday. Otherwise, actually the revision session will be similar to just revising the things that we have done so far. Like mostly an oral discussion, because what you'll see in the exam is going to be just some code snippets and you have to answer based on that. So if your basics of the coding are clear, which is through the OPP basically, you are good to go. Only week 12 is the week which is not covered in the OPP primarily. So that week you have to prepare, but sir will be taking session for that on Monday. Okay.
Sir, for end term of MLP, we have to revise the concept of MLT. Concepts from MLT means PCA, finding eigenvalues and eigenvectors.
No maths is required. Only some basics. Maths is not required. Basics in the sense like you should know that decision tree does not need feature scaling, right? Because it's just a question answer based model. Any model which has distance calculations like KN and K-mean, they will require scaling. So these types of concepts you should know.
Okay.
What is a hyperparameter? Is weights of a regression model hyperparameter? No, right? But neighbors of KNN is, because we have to specify that, right? This is what you should know.
Okay.
These things. Basics of each model. You don't need to do the math and all those gradients and formulas. That is not required. You can skip them. Okay, let me ask you a few questions. Maybe that will help you to revise, and that will be giving you an idea of what is to come as well. Similar thing, like similar type only will be coming. So that's how you should prepare. Okay, so first question. For train test split, if I write test size is 25 and train size is 75, will I get different splits or will I get same splits?
Sir, could you please repeat the question?
I'm saying I'm doing train test split. Okay. One in the first train test split, I have same data set and I'm writing train test split with train size is 75%, of course, and test size is 25%. In the second one, I write test size is 25. In the first one, I write train size is 75. Second one, I write test size is 25. Will I get the same data in train and test, or will I get different data in train and test?
Different.
A random state besides the...
Exactly, that was my question. So until and unless we have a random state, we can get different splits. Size will be same, right? 25, 75. That ratio is same, but the values will depend on random state. If you have the same random state, then same. If you have different random states, then different.
Yeah.
Okay. Yeah, that was the first one. Second question. So decision tree, we have a parameter called as max depth, right? So if I say max depth is equal to 10, does that mean the height of the decision tree is also 10, or is it something else?
To yeah,
9, sir.
9.
Exactly, right? The height is max depth minus 1, because we count the root as a depth as well, but in the height the root is not counted, right?
Yes, sir.
Yeah, so that is correct. Okay. For pandas, you should practice pandas. Please practice very well. You will see 4 or 5 questions from pandas surely. You should know how to do filtering, like data. If I want to see male greater than 30 years old, right? So we have practiced these type of questions in week 1. From the data set, I want to see the males who are greater than 30. So first you will filter the males, and then you will do the filtering of the age, right? So these types of filtering, how do you do it in code? These you should know. Okay.
Yes, sir.
Okay, can anyone tell me the difference between, okay, this we have discussed many times also, but this is quite important. What is the difference between fit transform, and transform?
Fit will train the models.
Okay. What about fit transform?
It will train as well as transform the data.
So where do I use it? Do I use it in model training, or do you use it in some pre-processing?
Pre-processing fit transfer in pre.
Yes, because those will first learn some parameters like the standard scaler. It will learn the mean and standard deviation, and then it will transform the data by applying the scaling formula, right? So that is why we will need fit transform.
Sir, you have taken three things: fit, transform,
And
and
transform. Third is
one.
transform. Yeah, what is the use of transform?
Like when we have already fitted the data and we have just to transform the test data.
Yes. So on test data, I will do transform, and on training data, I will do fit transform, right?
If we have trained some data on some model and apply on the test data fit transform, then what will happen?
Can you repeat once again? If we have trained some model and after that?
You have trained the model with fit transform. So now
Right.
that model is transformed and fitted with that. Okay. Now, if we apply fit transform again on test data, then what will happen with the test data?
It will give you an error because you can't fit on the test data. You will get an error.
Okay.
Okay. Because fitting on test data is not possible. So that is why you will always get error in that case.
Why it is so? Because suppose the model is trained, then it should work na, on the fitting also, in the transform also.
No. If your model is trained, fitting means you train it again. It's retraining. So why will you retrain a trained model?
Okay.
Right?
Okay. It will apply training of the same data on the test data. Okay.
Yes.
Okay, good. Okay.
That is the thing, because once you train, it is already learned. Like suppose regression, it has learned weight is 5. So when I do fit again, it has to again learn the weight. So what is the use of the initial weight, right? So that is where it will get an error, because already the weight is learned.
Okay. But it should not give error. No? It should give another set of model.
No, it will not give you that red color error. It will basically give you a warning error that the model has already been trained. So training it again will stop the original parameters.
Okay, got it.
Yeah. The red error won't be there. Like the code will still work, but you will get a warning error in that case.
Okay, got it. Thank you.
Yeah. Okay. Next is, okay, so random forest and ADA boost. These are two different types of ensemble models, right? What is the main difference between them?
L1, L2.
No, not L1, L2. That is ridge and lasso.
Yeah, regional. Sorry.
What is the question?
Random forest and XT boost or ADA boost. These are different ensemble models, right? But still, random forest and XG boost are very different from each other. What is the primary difference between the two?
ADA boost works on error by boosting it.
Exactly. So bagging and boosting, right? An random forest will take multiple decision trees and it will average out the prediction by bagging them. Whereas ADA boost, what it will do is it will basically train trees sequentially. First one, it's not good. It improves that, makes second one, which is better. And it goes one by one. So bagging is simultaneous. It trains all the trees at once. Whereas boosting is sequential. It does one by one processing. Okay. So that is the main difference.
Sir, could you please tell the difference between bagging and boosting again?
Bagging is sequential, simultaneous, right? It basically trains all the decision trees together and then it will do the averaging of the predictions. Whereas boosting will train one tree, then it will improve the other one by training the next one, then sequentially will train the next one and so on. So bagging is always together and boosting is one by one. That is the difference. Okay.
Okay, sir.
Yeah. Okay. For KNN, like suppose if I take KNN model, KNN can be used in classification, KNN can be used in regression. So how does it differ in both the cases? How does it make a prediction? Like for example, I give you an array which has 5 members and I tell you n neighbors is 5. So take all the 5 and first I want to do classification with the same and then I want to do regression. So how will my answers differ in both
For
the cases?
regression, it averages the nearest neighbors.
Exactly. It takes the mean, right? Yes. And what about classification?
It takes the maximum.
The mode
real-
basically, right? The mode, the most
Yeah.
occurring group. Yes. So that is how it does it. Okay. So that is one question. What about imputation? You have seen two types of imputation. One is simple imputer and one is KNN imputer, right? So how if I give you data and if I ask you to impute with both the imputers, so how do you think the difference will come?
Yeah, sir. One thing, what you said just before this question.
The imputer. I said two
Yeah.
imputers are there. One is a simple imputer and one is
No,
KNN.
no, 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 no.
So KNN,
Separately.
the nearest neighbor.
Uh,
Before that, what did I see?
KNN regressor and
KNN regressor.
classifier.
Yeah. There is a KNN regressor and then there is a KNN classifier.
Oh, okay. So how these two different, sir?
So KNN regressor, what it will do is it will basically find the n neighbors. So first of all, in KNN, if it's regressor or classifier, whatever it is, it has to find n neighbors, right? So in KNN
Yes,
regressor,
sir.
what will happen is when it has to find the n neighbors, it will find the n neighbors by doing averaging. It will find the n neighbors and the final prediction it will do is by averaging the n neighbors. So whatever value is there for the n neighbors, KNN will take an average mean of those values and that will be your prediction. Okay. Whereas when you talk about classifier, so in classifier, what it'll do is instead of doing the mean, it will take the mode. Like for example, I have 5 neighbors, 3 of them are 1 and 2 of them are 0. So my final classification will be 1 because I have 3 of them are 1, right? More is 1. So 1 is my final answer. Whereas in regression, since the labels are continuous numbers, my final values will be the mean of them, right? It will take an average and then give the final value. Okay?
Yeah, okay, sir.
Yeah. Others, are you comfortable with this now? Clear?
Yes, sir.
Okay. Okay, now next question was what is the difference between KNN imputer and simple imputer? So can somebody tell me that?
Simple imputer has strategy like mean, mode, and most frequent, mean, and constant.
Yes.
And
The
KN
major thing is if you see simple imputer, it basically takes the entire data set, right, to do the imputation. Like suppose I say mean, it will take mean of all the other samples to impute my current sample. Whereas KNN, it will also work with mean and all these things. But the thing is that in KNN imputer, I can specify which sample you want to work with, right? So KNN imputer will give me a specification of which sample I need to work with. And that is how it will basically do a better sequential job than the simple imputer. Is it like...
Sir, could you please repeat?
No, what I'm just saying is for simple imputer, the thing is straightforward. It will do the imputation by taking up the values of all the other remaining samples, right? Which is there in your data set.
Yes, sir.
Whereas what KNN imputer will do is KNN imputer will not take all the samples. You have to specify, right? You say k is equal to 5. So it will take the 5 nearest samples and then do the imputation based on that. That is the main difference, right? Because see, whenever
Yes,
you
sir.
have the word KNN, that means there is that k neighbors logic that is going to be applied. Okay.
Sir, the meeting notes will be there, will be shared because we are discussing that these are the question answers, no? Like that.
Meeting notes. The meeting is getting transcribed. I think you can get the transcription. It will be
Yeah,
there.
yeah. Please share in the calendar. It will be better helpful to revise these questions we are discussing.
Yeah, sure.
Right? Okay. Thank you. Please.
Yes. I will share the
Yeah.
transcription after the session.
Transcription
I'll just
will
add it to the calendar.
yeah. Your transcription, this discussion transcription will be very helpful.
Yeah, definitely.
Yeah.
We will.
Please.
I'll add up the transcription result.
Please. Okay. Please proceed.
Okay. It's going fine, right? Discussing like this, or you want me to discuss week wise? I think this is better. This will be a little less monotonous to discuss like this.
Collections are not there. Questions collection with such type of
You
things.
have previous year questions, right? You can go through them.
Yes, sir. Quiz
Previous year questions.
practice.
Like
Yes.
questions are not going to be repeated, but you will get a good idea from
Okay.
previous year questions.
Okay.
Yeah, I think there are many. Like say MLP is running for a long time, so there'll be a ton of questions that are going to be available. Okay, what about the models? Like which, like suppose I have a very complicated classification task. Which models should I prefer? Should I prefer simple linear models or should I prefer the bagging boosting based models?
Sir, could you please repeat the question?
Question, this is not a very good question actually, but the simple question that the models that I have simple linear models to work with my tasks, and I also have very complicated bagging boosting based models to work with my task, right? So which is better in case of a complicated classification problem or a regression problem? Which is a better thing to work with?
It will depend on the data set, no? Not on the model.
Yeah, exactly. So there is no universal thing here, right? It depends on the data set. That is a good answer. It is not universal because we can have one model which works very well on some data and the same model might do very bad on some other data, right? So we
Yeah.
don't have anything universal to say for this instance. We have to depend.
Absolutely right.
Yeah, but you have mentioned that data is very complicated. So what is the
No,
point of
even whatever the data is, there is no hard and fast rule. Okay. So whatever
If
the
the
data is,
reference lie on the same line, then linear models would be better.
yes. Generally it will be better. Yeah, that is true. But again, it is very subjective, right? None of the thing is straightforward here. We have to experiment and see which model is doing better for which case of data. Okay, so there is no subjectivity here. There's no objectivity here. It is completely subjective. Depends on model to model, what to be used, what not to be used, and so on. Okay. Yeah. About encodings, we have one-hot encodings, we have label encoding. So can you tell me what are the limitations of both of them? Each of them is good in its own way, but there are some limitations both of them have as well. So what are the limitations of one-hot encoding and what are the limitations of label encoding?
In label encoding, we not able to define the categories line by. If I want a small, medium, and large in 0, 1, and 2. So
Correct. That is very right. What
for
about
label,
one-hot? What is the problem with one-hot?
it is giving us a sparse matrix.
Yes, which is very large, right? And that is why it
Yes,
is not very
it's
optimal to
unnecessary
work with
zeros
it.
are coming here.
Yes, exactly. That is correct. Okay, what about another thing? Like suppose one-hot encoding I'm doing, will one-hot encoding help me to capture the semantic relations between different words?
No.
Why not? Like what is the
No,
reason?
sir. I think it will 0, 1.
Yeah, it will 0, 1, right? Because the distance is a problem. Because all the one-hot encodings, they have the same values. That is why when you take the distance between any of the two words, it will always give you the same value, right? So that is why one-hot encodings are not very good to capture semantic relations, and we should basically go on with techniques like TF-IDFs or embeddings to basically get better encodings, right? So that's what we discussed in week 10 as well. Cosine similarity, please learn cosine similarity. You can expect questions on that as well because that is an important concept. So we have discussed it in the week 10 session. So just go through that once again. I've explained you the formula and everything.
NAT questions will be there.
Which questions?
NAT questions on cosine similarity also will be there. Numerical questions.
Yeah, you can expect some.
Okay.
So just go through the formula. It won't be very difficult. Just go through the formula of how to calculate, like work. Like I showed that in the that session as well, where you take a tensor and you take a vector and you calculate right on cosine similarity between the two vectors. So
Yes,
just
sir.
formula once that we should do the work. It's quite easy.
Right.
Yeah,
Like cosine
sir.
similarity, Euclidean distance, Manhattan distance. These are basic ones, right? So this we should be comfortable with. Okay.
Yes,
In
sir.
week 8 or something. Sorry, Jaydev, you can.
Sir, yes, someone was asked that one hot encoder is yeah, we mentioned is first output equal to false. So that, and one question was asked by someone that it will become 0 0. It will take unnecessary
Space.
thing.
Yeah. Correct. It takes
So
space, unnecessary space.
when we will give is first equal to true.
Sparse equal to false will also take space. It will just change the format of the encoding. Space will always be taken, and no matter what type of one-hot encoding you have, it will always give you the space problem. Okay. So yeah, I agree. Like sparse equal to true, that is the thing, but that is just a change of format. You will not see any changes in the way the data is presented. You will always have a space issue in that case as well. So remember this as a universal fact. Whenever I have one-hot encoding, I have sparsity straight away. Okay.
Week 8 or something, image classification is there, no? What kind of questions are expected from there?
Image classification, only general, like not anything specific to images. General questions on the models, then on the pre-processing. No
So
specific for images.
in previous term PYQs, I don't find any question related.
And they won't be there. There won't be anything this time also. You can have general questions. There won't be any specific questions to image processing or something. That won't be there. That's not taught like in detail, so we won't be asking from that. General questions like this is which is a better classification model or which model is doing what. The basic on the models, right? The general model, not specific to anything to images. Only general questions will be there.
Okay.
Okay. Again, in I think one of the weeks we are TF-IDF. So TF-IDF again, you don't need to know the formula, but at least be comfortable with the code, right? Because TF-IDF is just basically it'll just you have to specify the embedding size, and once you specify the embedding size, TF-IDF creates the embeddings to that. And the advantage of using TF-IDF is that the embeddings that you get using TF-IDF, they are very semantically accurate, and for similar words you will get similar embeddings where the cosine similarity is going to be high, right? So this I think we know already. So this you should know, like how TF-IDF is a solution to one-hot encoding as a problem. Okay.
Okay, sir.
Then from linear regression, ridge, lasso. Yeah, ridge, lasso, the difference should be clear. Like what is ridge and what is lasso? So can anyone tell me what is the difference between ridge and lasso?
L1, L2 norm.
Yeah, the norm, right?
L1, L2.
So which can be used as a feature selector out of these two? Which can be used to eliminate some features?
Lasso.
Lasso, because lasso zeros out, right? It's
Yes.
a L1 norm which basically zeros out the features, some of the features, not all, some of the features. So because of that zeroing out, we can actually use lasso to select features, right? So that's the thing. Then you should know, like suppose I give you a regression model, it has two major things, right? Intercept and coefficient. So what are the intercept? Intercept means the bias, right? So in regression model you have wx plus b, that is the formula of regression model, right? So intercept, when you say the fit intercept, that means you fit that bias to it. When you don't say it or say it as false, then you're not fitting the bias, so you're just fitting the coefficients, and coefficients mean the weights, right? So w's, so that you should know. Then what about logistic regression? What are the outputs you get from logistic regression? Are they real numbers, whole numbers, or what are they from logistic?
-1 to 1. No,
No,
it is
0 to 1, right? 0 to 1. Probabilities.
Oh, okay, sorry.
Yeah, because you use the sigmoid function in that. So that gives you probabilities of values between 0 and 1. So 0, closer to 0 means low probability, and closer to 1 means high probability. Okay, so that's what we get. For logistic regression, there are two prediction ways that we have also seen during the OPP revision. One is predict and one is predict proba. So can someone tell me the difference between the two?
Predict proba is the probability actually which we are getting.
So do you get one probability or do you get one probability for every class?
One probability for every class.
One probability for every class.
Every class. And what about prediction? What do you get in that?
The labels.
The actual label. So basically, whichever predict proba will have the highest probability, that will be the predict output, right?
Yeah.
Yes.
Highest probability will be highest probability class will be given.
Classification will do. Yeah, absolutely. Okay, then grid search. Suppose I have 3 parameters and I have five values for each. How many grid search combinations do you think I will make?
125.
125.
5, 5, 5,
25.
right?
Yeah, so yeah, right. Sorry, I multiplied it wrong. Yes, 125. Because you have to multiply, right? So whatever is the number, you multiply and take all the combinations. Yes. Okay. That's 525.
So difference between randomized search and grid search.
Can you tell me what is the difference? Like, what do you think is the difference between the two?
Discrete and continuous.
Yes. So in grid search, you have to specify parameters as discrete values. Like I say, n neighbors will be 1, 2, 3, 4, 5. That is grid search. Randomized search, you will take all values in an interval. So I will say that you do n neighbors uniform
Range.
1 to 10. So you take all the numbers as a uniform distribution from 1 to 10 and do the parameter combination. So generally what happens is in randomized search, we can actually see a much larger search space. So we have many more parameters and we can do it in a very small code. We don't have to specify a list of all the parameters. We can just work with them and see what the total number of parameters are by specifying distributions. So that is the main difference. Okay.
Yeah, okay, sir.
Then basics of libraries you should know, like not memorize all of them. Like train test split is in model selection. This I think you have done in OPP, so you should not find this to be very difficult, but have a idea of it. Okay. Then linear model contains linear regression, logistic regression. These basics should be there. Like not very much, like you don't have to mug up all the libraries, that's not required, but just have a basic idea that should give you a good overview of where to look for which model, where to look for which preprocessor. That should be clear. For the scalars, min-max and standard, what is the difference? I think by now you are all clear with that, but you should revise that. So I hope all of you know the difference, right? Between min-max and standard.
In min-max, we are dividing by max.
Max minus
Yeah.
min.
Yes, so we are dividing x minus x min divided by x max minus by x min, right? The range. So what values do you get for min max? Are there any specific range of values?
-1 to 1.
-1 to 1.
Min max is -1 to 1. Are you sure? Or is it 0
No,
to
we
1?
get
Zero
maximum
to
thing.
one. Zero to one.
Yeah, it is a normalizer, right? So think of min max as a normalizer. And whenever I say normalize means you convert something as 0 to 1. So whichever are the higher values, they'll get converted to something near 1. Whichever are the lower values, they'll get converted to something near 0. Right?
Okay, sir.
Yeah, for standard scalar, you have other ranges. Standard scalar, basically what it tries to do is it centers the data. So the mean becomes 0 and the standard deviation becomes 1.
Z-score actually.
Yes, Z-score. It does the Z distribution on the data. So suppose I give you a data set, a 5-number data set with huge numbers, and I apply standard scalar and I ask you what's the mean. So don't sit and calculate the mean. You can straight away know it's 0, right? Because that is the objective of standard scalar. To make the data in a Z distribution, which means 0 mean and 1 as the variance or the standard deviation. Okay. So this basic difference between the scalars you should know.
Sir, could you please repeat for standard?
Standard, simple idea. Whatever data is there, don't think about what values you're scaling them to. Just make sure whatever the scaling is, the values have 0 mean and 1 as the standard deviation. So if I have to calculate the mean and standard deviation of the scale data, it will always be 0 and 1. Okay, that is the main thing. Then there is a formula x minus mu by sigma. That is the formula through which scaling is done. But the output will always have a 0 mean and a 1 standard deviation. Okay.
Okay, sir.
Yeah. So that is the focus in standard scalar. Then about column transformer and pipeline, I think now everyone knows the difference. So can somebody nicely summarize the two for me? What are the differences between column transformer and pipeline?
Column transformer works on individual columns.
Yes. And pipeline?
On the whole data.
So basically, suppose I have a data set which has 5 categorical columns and 5 numerical columns. For categorical, I will obviously encode them, and for numerical, I will scale them. So what is better? Should I use a pipeline or should I use a column transformer for this case?
Column transformer.
Right, because column transformer will help me to select those 5 columns and get me the encoder on those, and then select the 5 numericals and do me the numerical application on those, right? Whereas if I do a pipeline, it will apply the same thing to the entire data set, right? That is false, because if you apply a encoder to a numerical data, it is, and scalar to a categorical data, you will get an error, right? So pipeline will not work. So column transformer comes to the rescue.
Also, if we say like column transformer works in parallel and pipeline works in series, is it correct?
Yes, it is correct. Very correct. Because column transformer will parallelly process the columns and pipeline will do it sequentially. Like suppose you say simple imputer and then KNN regressor. So first simple imputer will be done and then the regressor will be done. Okay. Yes, that's correct. Then you should know about the basic loss functions and metrics, right? So
In the pipeline, we cannot specify columns.
no, we can't. It is for all columns. Pipeline will be applied to the entire thing.
Okay.
Okay.
So suppose if we have a random search, a random forest
Okay.
model, in that there was hyper parameter was given, how we can calculate the unique combinations.
You just multiply, right? So suppose I say n neighbors 1, 2, 3, 4, 5, and not random for something else, then criterion is Gini and entropy. So you have 5 values for n neighbors, you have 2 values for criterion. So what are the total combinations? 5 into 2, that is 10. So just see the number of parameters for each, like number of combinations for each parameter, and multiply them. Okay.
Okay, sir.
Yeah. So that is the thing. Then you should also, like for all the models, just know the main parameters. Okay, like then neighbors for k neighbors is the main parameter, and for regression you have that fit intercept, that is a good parameter. Then the model.cof, model.intercept, how to inspect the model, right? Those things which we have seen in the lectures and the live sessions, that should be good to go. Metrics, please revise metrics very well, because you can expect questions on computing metrics. Like you get 2 arrays, you have to compute the mean absolute error. You have to compute the sum of squared error in clusters. You have to compute the accuracy score, right? So these metrics we have discussed in regression, and for classification, we have discussed them in detail in week 7, right? So with all the formulas, how you have to compute. So please practice accuracy, precision, recall, inertia. These are metrics you can expect numerical questions on, right? So practice the formulas, go through the formulas and practice once with your own, like just take 2 arrays and just work out with the scores with them, and that should give you a good idea.
Okay, sir.
Okay.
Sir, could you please explain about leave one out and the cross validation score?
Cross validation score, what we'll do is, like for example, your dataset has 100 values and I have to do accuracy score for them, and I said cross validation is 5. That means what we'll do is, for every time it will divide the data into 5 subsets. For 4 subsets it will just train the data, and for 1 subset it will actually calculate the accuracy. Then in the second iteration, the accuracy will come for the second subset. Third iteration, the accuracy will come for the third subset, and the other 4 will be used for training. So basically in 5 iterations, I will compute 5 accuracies, right? Once for the first subset, then for the second subset, then for third, then fourth, and then fifth. So what is my final model accuracy? It's the average of the 5.
Okay, sir.
Okay. So first you basically divide the data into those cross-val CV, the parameter CV, right? You divide it into those CV number of subsets, and then compute the metric for each subset once in one iteration. And then your final metric will be average of all the subsets. Okay. Accuracy is for classification. Of course, if you have it in regression, you will do MSE or something like that, right? For regression, and do the same thing on all the subsets. Why it is used? It is
Yes,
just
sir.
to prevent bias. Sometimes model becomes biased to some data, and if we compute metric on that, we might get good metric, and some other part of the data we might get a bad metric, right? So what crossfire does is it just generalizes, takes an average and sees how, and overall how your model is actually doing. Okay, that's the thing.
Okay, sir. And sir, leave one out. Leave one out.
Leave one out is this only, that 1 goes for testing and 4 go for training in 5, right? So at every subset, every stage you divide into 5. First 4 for training, last for the accuracy score, right? Second iteration, take first 3 for training, fourth for accuracy, fifth for training again. So just leave 1 for accuracy, that is so not accuracy, inference, which is the metric calculation, and all the others will be for training. That is the leave one out. Okay, this is the default is leave one out only. You have to prepare this one. That is sufficient if you prepare this.
Okay, sir. There was a one question. Could you please explain that?
Can you share it?
Yes, sir. 1 minute. Sir, this question.
Just a minute. Yeah. So for a dataset with 100 points and 1000 points and 100 features, the following code will generate how many models during execution? Okay, so you're doing a leave one out and you're doing cross val which is equal to leave one out. So what do you think? What do you think will be the answer for this?
1,000.
So you have 1000 data points. Yeah, so number of features does not matter, right? Here you can ignore the number of features. So you have 1000 data points and you are leaving, basically you're not specifying any partition here, right? There is no partition that you are specifying. You are
Triple
just saying
line,
that, yeah.
triple line, or
No. First, try to understand that this leave one out here. In general, what happens is in cross validation, we specify partitions, right? Partitions data into 5 subsets, right? So in that, you will have models like models will be there for training and one will be for inference, right? Here, we are not specifying any partition. So what we are saying is you just apply default leave one out, which means that in 1000 points, you do 1000 partitions. And in each of the 1000 partitions, you basically take 999 for training, and so 999 points for training and 1 point for evaluation. Okay, that is what this means. So what will happen here is, even though here there are 1000 points, you will have 1000 models. 999 models will be used for training and one model will be used for evaluation. Okay, so 1000 will be the answer. 999 for training, one for evaluation at every subset. So 1000 models will get created in every iteration. Okay, that's the answer. 1000.
Okay, sir.
If I say partition, like if my data is partitioned into 10 subsets, then I have 100 points per subset, right? So I will just have 10 models in that case. Here by default, there is no partitioning. So I will have all the models because every point will be one model. Okay. This is the default one actually. So just
Okay, sir.
remember, number of
Samiti,
partitions is number of models. Okay, one model for each partition. And
Samiti,
if there is no partition, then each data point will get one model because I'm not partitioning or grouping them at all. Each one gets one partition. Okay. This is 1000. Clear everyone? Any question on this?
yes, sir. So, submit it once. Let me see. Yeah, just to go, just do it. Your flow will stay continue. Just uh,
Which question?
this question. Yeah, you go on learning mode and submit it. Your flow will stays. No problem.
You have a doubt in which one, Jaydev?
Yeah, no, I am telling just I want to see this answer of this. Then it will feel good.
Number of questions are around 40, sir, per
No,
for
30.
Yeah.
30 questions.
time
Okay, 1000. 1000
duration.
is correct. Yeah. Can you repeat?
Duration is it 2 hours for NTEM or less
No,
than that?
1.5. 1.5 hours.
1.5
Like the
hour.
other subjects, 1.5 hours.
Okay.
But you can actually, I've seen the questions are quite easy. You can finish them in 45 minutes.
Yes, sir. Questions are easy.
This term's paper is slightly easier than PYQs because we have made sure there is no question that gets repeated. So all new questions are there, and that is quite easy only. It's not very difficult. Definitely, there'll be 3-4 questions that you have to spend some time deciphering, but most of the questions by default will be on the very easy to medium side.
Sir, can you once discuss what is make pipeline means difference?
Make pipeline, I think, is for making a custom pipeline with like it is for simplifying code. It simplifies the code for pipeline. It does not do like any special feature. It just simplifies. You can directly merge two pipelines into one pipeline, something like that. It does. Also, not I don't remember it very well because we don't use it much. It, I think, is for merging. Two pipelines are there, and make pipeline merges the two pipelines into one pipeline. It's probably for that, but you can ignore it. Like, we don't use it anymore. It's not a very useful feature. You can skip it.
Okay.
Yeah, yeah.
Do we need to focus on syntactical errors also, or
No, no, no. You don't
that
need to. You have to focus on the logical errors. Like, suppose I do that fit transform instead of fit, right? That is a logical error. So on that you have to focus, not on syntactical. That won't be asked. Error, like, in the sense, there won't be something like find the error here or something like that. That won't be there. But just like sometimes we can give you a wrong code and ask you the error. So
yeah.
like instead of fit transform, you did fit, right? Instead of fitting a KNN regressor on classification, you fit sorry KNN classifier on classification, you fit KNN regressor, and then you want classification done, right? That's an error, logical error. That type of error we should know.
We need not be keen on syntax. No, that's what.
No, no, no. Just the basics, basic syntax. That is basically the general idea.
Okay.
Not anything on the special syntax. Okay, just the basics. So just go through live session collabs. That should give you a good idea. And then of course, if you have time, go through the lectures as well. Just see the PYQs. That will give you a good pattern. In the PYQs, mostly no question is on syntax. It is mostly on logic. Okay, you have to see a snippet of code and see the logic. Like for example, if I give you a grid search code and I ask you how many models will be made, then just decipher the models and you multiply, right? That becomes your logic for that. So that type of things can be there.
Okay, sir. Sir, could you please explain about polynomial feature?
Polynomial feature simply means that you specify, you create more features by multiplying the number of features by the number of models. So for example, if I say
Sir, you are not audible.
yeah, sorry, I had a power cut. Can you hear me?
Yes, sir.
Yeah. So polynomial features, what it does is using the given features, it does some combinations, polynomial combination, like it can square a feature, it can multiply multiple features, it can add up some features, and it creates new features using that. So if I say degree 2, that means you just maximum degree of a feature you create is 2. Like it can be x1 plus x2, x square, x1 into x2, but it can't be x cube, right? Because that is not allowed for degree 2. Okay, that's the it basically it's a combination of features in different degrees so that it can create new features using the existing ones. Okay, and the combination will be such that it specifies the degree. It cannot go beyond the degree. Like if I do x cube, that is degree 3, right? So I can't do it with degree 2. I have to change the code for that. Okay.
Okay, sir. Sir, when can we include bias and when not?
I think it is more for two things. One is the regularization, and second one is for including the bias term. Here, the answer is the first one only. It is to include the bias term. Can you just check it once? This question is actually a little ambiguous also because include bias is a parameter for, yeah, it's correct, right? Yeah, including the bias. So it also helps us to regularize in some way, but the main thing obviously is you include the bias, right? Wx plus b. So include that b. That is the main thing. Okay, so
Okay, sir.
yeah. Any other question? Anyone has any other
How
doubt?
bias is helping in regularization?
It does not help in regularization, but what happens is when you have more parameters, the model tends to overfit less. So it's an indirect way of preventing regularization. Like I was saying, that option can be partly correct. It is not absolutely correct, but partly you can say, because if you increase parameters, models tend to overfit less. So that is the main reason. Otherwise, it's not correct.
Sir, like And so what we should follow? What is the question is given or the code below is given?
Both you have to follow, right? Like question will be code based, so you'll have a question statement and you will have a code snippet, right? So both you have to follow for that.
Yeah, because yes, sir. In this question, here it was given the include by is equal to false, and the question was asked, what does the include by determine? So
See here, so you follow the question only, but you won't see such ambiguities. The question will be very clear in the end term. In the PYQs, there are some ambiguity somewhere, so those types of things you won't find this time. It's going to be pretty straightforward. Okay.
so eh, uh, this question, like, so here it was ambiguity, isn't it? So there was a mistake little bit.
There was not a mistake, kind of like not exactly a mistake, but yeah, some slight ambiguity was there. But these types of ambiguity you won't find in R1, in our paper, which will be there this time. You won't find any such ambiguity. It will be pretty straightforward. Any doubt in pandas? Are you all clear with pandas? Like any question in pandas which has a doubt?
And no, sir, in this paper, I have no doubt.
Yeah, so pandas just practice the week one collabs, right? Which we had discussed in week one. And it'll give you a good idea. Like at least you'll get an idea of what type of syntax you have to remember. There is not much syntax, you have to remember the logic basically. What different functions of pandas does, how does pandas do statistics, how do you see data type, those things, right? So just very basic things. That should suffice. Okay. Now, any other question? Like that is it from my side. If you have any other question, we can discuss. Rest have, I think, shared enough ideas like on what type of things you can expect. It won't be like very difficult. It should be simple.
Numericals, I'm seeing numericals from MLT type questions over there in MLP.
What type of numerical have you seen? Can you give me an idea? Like,
Okay, I'm sharing you the screen. This sort of question we have to calculate.
one second. This is dummy regressor. What is the dummy regressor? It's just the mean. You have to take mean of all of them.
Given strategy is equal to median.
Median.
Oh yeah, sorry, median. You have to take median. Yeah, yeah. By default, it's mean, but here since it's given strategy is equal to median, you have to just take the median. So your input is this. So your output is just the median of this. No, wait. It's not.
Sir, how we can do this?
No. It's not the median of this. Okay, here that means you have to learn. Okay, this is training based. This kind of question won't come. You have to train the model for this. Is actually a code based question. You have to write the
Sir,
code and train the model and then get it with the median. No, this won't come. Just a
Okay.
minute, just a minute, just a minute. Go
sir,
down.
this was done last term
No,
of
no, no.
paper.
Actually, sorry. It's a dummy regressor. I'm sorry. So what happens in dummy regressor is in your training data, you have this Y, right? Y column. So whatever the strategy is, your prediction will be the strategy on the Y column. So it is going to be a median of Y. What is the median of this thing? Like just arrange it in ascending order and see what's the median. I think it's something around 11 should be the
9.8,
median.
10, 11, 11.5.
It's an even
11.5.
thing. No, it'll be a mean of two things. It's an even. It's an even
1, 2,
data set.
3, 4, 5. 11.5 and 11.1 mean.
Yeah. So what is that? That's going to be no. That is not. No. 9.8 and 10.9 and this. It will be a mean of something in 10 and 11. One value of 10 will be there. One value of 11. Yeah. Just copy it and just calculate the median. That will be the answer. Dummy regressor simply means you have the Y, you don't learn anything. You have the Y column, whatever operation is given, do it on the Y column, and that's your prediction. You get the same prediction for all the data. There is no learning. Dummy regressor has no parameters, it does not learn. That is why this question has been given. So there is no calculation here. You just have to take the Y column and do the operation. Default is mean. Since here they have given strategy is median, then you'll have median for this question.
Okay. 11 is the median.
So is 11 an option?
11.
Yeah, that will be the answer. So dummy regressor, never see, it will always give you same value for all data. Like whatever data you have, you always get the same answer for dummy regressor. Okay.
Okay.
So I was getting 11.3.
How you were getting 11.3? Like what did you do?
So the sum of two values like 11.1 and 11.5. It's 22.6
No,
by
no,
dividing
11.1, 11.5 is not. There is one value in 10 and one in 11. Those you have to take.
11.
10.9 and 11.1.
so
Yeah.
11.
This is just median. Okay. You have to first arrange it in ascending order and then calculate median. This is directly a median based question. You don't have to I think you have calculated the median wrong, Disha. This is median calculation. It will have a 10 point something. It won't be 11.
I have given the formula itself.
Yeah, yeah. Just follow this formula, Disha. That is the answer.
Okay, sir. Okay, sir. I was doing.
These are the, like, you have to sum it. 11 is the answer.
Yeah. Any other question? I hope this is clear, right? Now understood. Right? Whenever you have dummy regressor, just whatever you have the y given, apply the value on y and you will get the answer straight away.
Knife based is incorrect.
Knife base, you can ignore. It won't be asked. Just know the basics of differences between different knife base architecture.
This Minkowski has also come in our this. What is this actually?
Minkowski is a distance formula actually. So what it does is it does a different distance computation from your normal one, from the Euclidean and Manhattan. So see, I'll show you like just a minute. There's some example through which I can show you. It's a distance formula. It is like this. So you take a norm here, which is a degree norm, and then you just subtract the data set using the degree norm. So can you just search Minkowski? Like someone was, I think I'm getting some error in screen sharing. Something is freezing on my screen. Can someone just share the screen and write Minkowski distance? Just write it down. I'll explain you the formula from there. It's a distance value actually. There is a norm that is given, and you take a distance between that norm. You use that norm formula and take the distance. Yeah, this is just write Minkowski distance. You will get the formula from there.
Sir, are you speaking?
No, no, I'm waiting for the formula. Yeah. Yeah. So see, you do this, you have a degree, a norm which is given to you. So first you just do the absolute difference between all the values, just like the mean absolute error. You take it to the power of that norm, and in the end, you do it's like a square root, okay, with a higher number. So you do the square root of the thing with the root, not the square root, the nth root. So it is simply like the mean squared error only, but instead of using the square and square root, you use the higher degree root than mean squared error, right? You take the root of some other value. Like degree can be 5. So you do x1 minus y1 to the power 5 plus x2 minus y2 to the power 5, and you take the fifth root of it, the whole thing. Okay, so instead of doing square and square root, you take the nth root in Minkowski. So can you go back to the question? Like in that question, there were some degrees given, so those will be the roots you're going to use. Yeah, just go to the Minkowski question. It's just a calculation, okay? Just like Euclidean distance, you have a calculation there, and you just have to calculate it with that degree of root.
Which question paper was that?
Who was showing it? So can you just maybe reshare it? Who was sharing that Minkowski question?
Yeah, Abhishek sir, Abhishek sir.
I hope you understood the formula, right? You have to just do it's like a Euclidean distance, but instead of doing the squares, you take a higher degree number for doing the degrees, right? That's the only difference. Rest is same. It's just like Euclidean in a higher space.
Yeah, I'm sharing the screen. Just on it.
Yeah. Yeah.
That p is equal to 1 is the parameter for that.
Yeah, p equal to 1. Yes, that is the parameter. So whatever is the value of p, you do the squaring and rooting by that p. So first one will be x1 minus y1 to the power 1. The third one would be x1 minus y1 whole cube, and then you take the cube root of all the values, right? And the fourth one, you take the power 4. So it's just the Euclidean distance, but with a different power value, which is going to be given to you, which is given in the options, right? That's the only difference. Rest is same.
Okay. So for that we have to remember the formula, or we will be given the question like formulas in
I
the
don't
sheet.
think any question is for. I don't know. Like, no, formulas are not given. So just see, don't have to remember, right? So you just know it's a Euclidean distance, but instead of doing the square and square root, you just do a nth power and nth root. That's the only difference, right? Just remember it like that. Don't learn it separately because it's just a variation of Euclidean distance. Now, everything else is same.
Okay.
Okay, yeah, it's not a very different formula. It's just a different variation.
Okay. Thank you.
Yeah. So
Sir,
again, you don't have to remember much formulas. This is the basic metrics. Those formulas, if you remember, that should be sufficient. Yeah, Disha. Yes.
sir, I have doubt in two questions.
Yeah, please share them. This one.
Yes, sir, how we can calculate the output for this?
So for this, you have to actually do MLT. You have to write the perceptron equations and calculate. But you won't find anything like this time. You can ignore this.
Okay, sir.
Yeah, this is actually, see, you've learned the working of perceptron, right, in MLT. So that you have to do. You have to do the WX plus B, update the perceptron values, and do the classification.
Okay, by default, the cycle will be given, no? So by default, the first data point will be taken first.
Yeah. First, then second, then third, then fourth in the sequential order.
Okay, sir.
See, as it is for this one, the data is clearly linearly separable also. You can just plot it and see on which half does the point belong to. It should be, I think, one, the first half, probably. And get it. In case it's not clearly separable, then you have to write the equations and solve it. See, most of the questions will not involve rigorous maths. If such a question comes, it will be mostly on the conceptual thing. Like if it's linearly separable, then you just draw the graph and see where the point belongs to. Right. So these are MLT based. These are not much on the MLP part as such. These are mostly on MLT based questions. Yeah. Any other question, Disha? You were having one more, right?
Yes, sir, how we can calculate classes? Like,
So classes means, what do you think is classes? Classes means the output, right? How many classes? Yeah. So it's given, right? 3 classes, 1, 2, and 0.
yes, sir.
Yeah. So 3, right? That's the answer. So classes simply means it will give you all the classes, and when you do the len of it, you will see the number of classes, which is going to be 3 in this case. Right? So that's straight away 3. Got it?
Yes, sir.
Okay. Anything else?
Yes, sir, this question. How we can.
So you have,
Uh, Sir, actually, uh, the recall score we can calculate, but from code, how we can.
See, it's again a dummy classifier question. You see that in dummy classifier, your strategy is most frequent. That means the mode, right? And it is given that out of 1000 samples, 650 samples are class 1. So dummy will do the same output for everything. So what's the output? It gives 1 as the output for all the 1000 classes, right? But in actuality, you have 650 classes which are 1 and 350 which are 0. So now you got the distribution, right? So you have the true positive, false negative. You can calculate from this and straight away get the recall.
Okay, sir.
The only thing for dummy is it will do the same thing for every class. So since 1 is the most frequent, 1 will be for every class. And in the actual data, you have 650 for 1 and 350 for 0. So now you have both the y true and y predict, right? Which is there with you. So now you can calculate the recall straight away with the formula.
Okay, sir.
Yeah. Okay. For recall, precision, accuracy, please remember the formulas because they will not be given, but the questions will be there. So you have to learn formulas. Okay. So make sure that you know the formulas for all of them.
Okay,
We have
sir.
discussed them in week 7. So week 7 was a very short live session. So just go through week 7 live session 1. That's what I'll advise. You'll be able to solve many questions based on that. Like all the questions on those topics, you'll be able to solve very easily with those sessions. Okay. Any other question?
Regarding vectorizer, can we combine other features, numerical features, with the vectorized feature?
We can, but generally, like we don't combine. It is only for categorical features. We just create a embedding for that. We don't combine in vectorizer. It is only for text. It's a text vectorizer.
Okay, so we can predict only with that field.
Yes, exactly. We can only predict with that field.
Okay.
Whatever text is given, irrespective of the length, it can be a short text or a long text, but we'll have to predict with that text only. Okay.
Just on a quick note, if you can just give a brief on how one hot encoder is being replaced by this.
See, one hot encoder simply means suppose you have 5 words. So each word will have a 5-dimensional embedding where there'll be 1 and 4 zeros, right? So for apple, I'll add 1 0 0 0 0. For banana, it will be 0 1 0 0 0 like that. The 1 keeps shifting. But for TF-IDF, you again get embeddings, but these will not be zeros and ones. You'll get real world numerical values like 0.45, 0.35, 0.25 like that. And the vectors will be such that similar words like apple, banana, mango, they are fruits. They will have vectors which have very little distance between them. So the vectors will be very similar. Okay, whereas different words like apple and human, they will have very different embeddings because they are different, right? So I need to have that semantic difference between them. That's the only thing. For one hot, you will have same type of vectors with one single one and multiple zeros. Whereas for these, you will have real world values, which will make sure that similar words get similar embeddings and different words get different embeddings. That's the difference. Okay.
Okay, sir. Okay.
Sir, what is data snooping?
Data snooping.
Yes, sir.
You have a question on this, like in PYQ?
Yes, sir.
That was a part of transfer learning actually. Since transfer learning is not coming, you can skip that. Okay, week
Okay,
11.
sir.
Earlier we used to have week 11 in the end term, right? This term we have decided to remove it. So that's why you might that is for everyone as well. You might see some PYQs on week 11. So for now, just skip them because they'll not be asked. Okay.
Okay,
Week
sir.
11 is not a part of your syllabus. Your syllabus is 1 to 10 and 12. And 12 is a dense week. So please start going through 12 in case you have not gone through yet. Go through it and it will be covered in live session next week. But still, just go through it because it is a dense week. It will take some time to grasp it. Okay.
Sir, except 11 and all other are our
Yeah. Except 11, everything is there. Okay. 11 is the only one which is not there. Rest all the weeks are there. 11's topic is transfer learning. That is the topic we will not be asking this time. Okay. So skip 11. Rest all the weeks you have to prepare.
Okay, sir. Sir, which algorithm will may get affected by
Affected by?
feature scaling?
So this we have discussed. Can you remember like what we had discussed? Can you tell me like if you can try out which ones like in general, which ones will be affected by scaling and which one won't be?
A sport vector machine.
all the algorithms apart from decision tree based algorithms will get affected. So what are the decision tree algorithms? The random forest, XGBoost, AdaBoost, these are all tree based algorithms, right? So
Yes,
apart
sir.
from these algorithms which use a tree, every other algorithm gets affected. Okay, so SVM, linear regression, ridge, lasso, KNN, K-means, all of these get affected by scaling. Okay, so this
Okay,
you
sir.
should know. Yeah. For K-means, yeah, clustering we have not talked about. So for clustering, there were two types of clusterings we have discussed. One is K-means and one is hierarchical, right? Which we had discussed in the agglomerative, basically. That was called as agglomerative. So, and also I had shown you with examples, right, how the two work. So that you should be clear with how the two K-means and agglomerative work and what are the differences between the two, right? That should be pretty clear. Evaluation metrics for k-means and agglomerative are same. You have inertia, which is just the square of distance from the mean of each cluster. And the second one was chill out score. So again, for chill out, you can ignore the formula. It's a very big formula. Don't need to remember that. But at least you should know that what are different metrics for k-means and your this one, hierarchical, right? And also if a data set is given and if we ask you to perform k-means on it, a simple one or two iteration based k-means, or if we ask you to perform hierarchical on it, you should know how to do that. For that, if you have a doubt, go through week 9 live session 1 and 2. We have discussed it in detail and that will help you to solve those questions.
Okay, sir.
Yeah, so that is about k-means. Any other doubt? Like apart from that, I think rest of it is pretty straightforward. You can try out, and next week also, like sir will take session for revision. So in case if you encounter more questions and if you have doubt, you can ask us on Discourse or you can ask it in the next live session. Okay.
Okay, sir.
Yeah. So anything else you want me to talk about today, or otherwise we can wrap up for this session and we can meet next time. Probably we won't be meeting like from my side. This is the last session, but anytime we'll meet in some other course. Yeah.
Sir will be doing week 12 in next session.
Yeah. Manoj sir will take week 12. We will cover it in next session. Okay. So Monday, Thursday, and Thursday sir will also do revision after week 12. Okay.
Okay, sir. So could you please tell important topic or its whole week was?
No important topic. Whatever we discussed, practice that and go through live session content. That should be good to start with. Otherwise, it is everything. But don't go on like mugging up of the very difficult parameters of all models. Just go through basic parameters. That will suffice. Okay. And pandas, please practice. For pandas, like week 1 live session was good. So you can practice from there. The rest is like straightforward, not much difficult. But yeah, no such important topics. Everything is going to come because there are 30 questions, right? So 30 questions will cover up almost everything. Okay. But yeah, it's going to be easy. Just go through the content once. It should be easy. You'll be able to revise it quickly. Shouldn't be an issue. All right. Yeah. Thank you so much.
Yes, sir.
Thanks, Disha. Thanks a lot, everyone. Okay. So all the
Thank
best.
you.
We will meet next week. Yeah. Yeah. Jaidev, anything?
No, okay, sir. Thank you, sir.
Yeah, thanks a lot. We will meet soon as well. And again, next week, Manoj sir will be doing revision. So join the sessions and for week 12 as well. So we'll cover next week. Okay. All right, then. Thank you, everyone. So all the best for end term and hopefully everyone will do well. Okay. Thank you.
Thank you, sir.
Thank you so much.
Thank you, sir. Thank you.
Thank you. Thank you. Thank you.